Hi, welcome back to tutorial 5 of the Altium tutorial series. So in between the last episode and now, I did some minor changes. I moved some things around. I moved the designators. I actually want to talk about that for a second. So you can see now that all of my component designators are moved inside of their footprints. And that's pretty easy to do if you just click on the designator itself. It can actually be hard right now because it's inside the component. So one thing I can do to fix that is make it so that I can't select components. And then when I click there, instead of selecting the component, it's going to select the next best thing, which is the designator. And I can move it around. And I can put it wherever I want. I can rotate it, just like everything else. And the interesting thing is that I can move that by itself. But if I move the entire component, it'll move with the component. So if I want to move both at the same time, I select the component. If I just want to move the designator, I can just select it. And I'm going to move it inside. The other option is to shut off designators, and the reason you might do this is if you have a very small board and you don't have a lot of room for them, and you know where to put each part. Maybe you'll refer to a printout of where all the parts go or something. Usually you keep these here because it makes it a lot easier to identify parts and assemble the PCB later. So if you can leave them, you should, but if you need to, you can also use this button to shut off the designators. Of course, that would be silly to do in this design because we have so much space available. One tool that I wanted to talk about a little bit was the distribute tool. So if I select a bunch of things, I can hit A, and then I can say distribute vertically. And that's going to ensure that the spacing between these components is the same. It's just going to look really good when they're all lined up. And they don't even necessarily have to be aligned vertically to do that. I could do it either way. That's a very handy tool. You can distribute vertically and horizontally, so I suggest you do that. But in this case, I'm actually going to move this part here because it makes more sense. I just want to draw some attention to that tool. The alignment menu is really helpful, so spend some time looking around there. And with that, I want to move on to the next thing. So the next thing is the View Configuration tab. Okay, so if you come to your side panel, you'll see View Configuration. If you don't see it, another way to get to it is to just press L. And then it should come up either as a floating window or it can be docked. And this is a great panel because it allows you to hone in on specific parts of your board without any distractions. So for example, if I want to route my components and I don't want all of this silk screen blocking it, I can just disable all of the silk screen at once. And it'll actually remove it from this bottom tab too, which is good because there's a bunch of things here we're not using. So let's go through and clean this up a little bit. For this design, which is a super simple design, we're not going to use mechanical 13. I don't need 15 right now. I don't need a keep out layer. I don't need, let's see, top 3D body. Yeah, that's another one. I don't need this. I don't need the assembly layer. I don't even need component center right now. Courtyard. So as I do this, there's not going to be solder paste or, yeah. So as I do this, this bottom panel is going to get shorter. And for right now, I'm actually going to hide everything in the bottom layer. I can do that by just clicking this bottom right here, and that's going to take out most of that layer. And I'm going to keep going. I'm not going to need these at the moment. I can always come back here and bring them back when I'm ready to use them. So now it'll be a little easier to route things, and I can quickly switch between my layers while I'm doing things and only see what's relevant to me. So now that I've got that, let's talk about actually doing some routing. Finally, let's talk about routing. So I'm going to start on the top layer of the board. And to route something, we've mentioned this before, but it's Control W. So then I get this crosshair. This is going to be the start. I can place it. Let's place it right here. And then we can see I'm drawing a line. And this is a plus 5 volt line. So like I mentioned in the last tutorial, I want that to be a little thicker. So if I press 3, hold on, let's hit tab, I can get some routing options. So I can see my different widths. These are the minimum, preferred, and maximum widths. I think that I need to fix my rules from the last time I changed them, so let me briefly do that. Width. Yes. I need to actually change this rule. I made an example rule that targeted traces that are within the 5 volt net. And I want to set that to have a 20 mil minimum. We'll do a 30 mil maximum for this board. Again, please do some research, use an online calculator to find out what your traces should be for a given board thickness. Remember that copper thickness is measured in ounces, so probably a lot of boards will use like a 1 ounce copper. So you can use that number combined with the estimated current that you'll be carrying to get a proper trace width. If I hit OK, now that is going to change itself. Perfect. I want to set my snap a little smaller. I like to use 5 for most of these things. And I can start dragging and doing these things. So you can see there's little bubbles around these. And right now, I'm in the walk around obstacles mode. So how can I change that? If I hit Shift R, you're going to see on the right side of the screen here, this is a conflict resolution mode. Okay, so hitting Shift R is going to change my conflict resolution mode. So it's up to you what you want to use and what makes things easiest. I recommend stop at first obstacle or walk around obstacles. You can also choose like push obstacles. You can experiment and read online to like see what these do. Basically, some of these will move elements out of your way while you're routing, which you may or may not want. Other ones like walk around are going to do kind of what they sound like it's going to walk around the obstacle. Like you can see it's starting to curve around this thing. So I'm going to leave it like that. By the way, just let me quickly, I think I've mentioned this before, but my colors are going to be different than yours because I've customized them. If you go into your view configurations and click on the colors, you can actually change these. So for example, I can make my all of my top layer like bright green or something like that. I don't like that color. I think it's kind of hard to look at. So I'm going to keep it how it was. I think it was something like this. Maybe I'll leave it like that. It'll be a little easier to see if I leave it like that for now. That's super easy to change. One thing I want to do, okay, so there are some different philosophies and different standard practices when you're routing. There's actually a lot of like best practices. I recommend doing some research online because there are a lot more things than we can probably mention just in a single video about routing. So I'll give you a couple. One thing is that we try to avoid sharp corners and turns. So we try to avoid 90-degree bends. Here's an example of one of those, something like this. We typically don't want this to stay. If I hit Shift S, by the way, I can hide everything but the top layer. We typically don't want these to make it to the final design. Luckily, Altium offers a tool that will get rid of all these automatically that we can apply at the end. So I'm going to show you how to do that. So for now, we'll leave it. But this is not something that we would generally want to see in a final design if we can avoid it. Other best practices, it's a good idea to, one thing I could have done is gone straight through like this, hit this pad, and then kept going. You'll hear a lot of people tell you that it's not a great idea to, make it so that the only way to get from this point to this point is to go through a component pad. Generally, it's a safe practice to actually offer a path that does not necessarily intersect a component pad like this. So there's a trace that goes directly to this pin as opposed to, cutting through. Let's keep going with these. I think what I'll do, so, this part is probably the most creative part of designing a PCB. So you can have fun with it. Just do your best here. I think I will go up this way. I think this is the last 5-volt line here. Yep, can do this. Can do this. And this is going to take a little while, so we might fast forward through it, or maybe I won't talk for the entire time. I can select small segments, delete them if I want to make changes. I can do this. In this case, these two pads are actually for the same component, and because of the way this switch is constructed, we generally short the two pads together. So I could probably have drawn just a trace between here and here. But I think for this example, it'll work to just do it as I have it now. And then I'm going to start doing my other ones. So you're going to see that those automatically draw at a different width because remember we set a specific scope for two different rules. So now this rule is going to have a 15 mil preferred thickness as opposed to the 20 mil preferred thickness. Actually, I think it was 25. Yeah, like I was saying, when you go to route things, once this is down, if you press 3, you can cycle through your thickness settings from your rules. So right now these were set to 20. We can change them pretty easily if I select them. By the way, if I select one track and I hit tab once, it'll select all connected tracks. And then I can change the width of all of those at the same time. So I can say 25, and it'll just automatically do that. If I have another +5 trace, let's find one right here. And I'll hit 3. Yep, so now it's 25. One more thing I can do is if I hit this, I hit tab once, I select the connected. If I hit tab again, I select everything that's part of that net. And if I hit tab again, it'll select everything on this entire PCB that is part of the +5 volt net. And if I hit tab again, I'm back to my original selection. So that's a nice trick for speeding up the work. All right, so I'm going to continue on with some routing. So one thing that I'm noticing right away is I have some nets that cross each other. And there's a couple ways to deal with this, but the easiest way is to leverage the fact that these holes actually go through the PCB and out the other side, which means that I can use the bottom layer to route them. So if I hit asterisk on my keyboard, I switch to my bottom layer. I can also just select the bottom layer, Control W, and now these traces are on the other side of the PCB, so I can actually cross them and they won't make electrical contact. So this is a pretty easy board, and there are no surface mount parts, but of course the process is actually the same if there are. The only difference is that if you have surface mount parts, obviously the pads will not be on the bottom of the PCB, they'll only be on the top or the bottom. So I need to get from the top to the bottom. There's an easy way to do that. So if let's say I'm routing something, obviously I already said I'm not doing ground, but just for the example, let's say I need to dip under this and get to the other side. So that's when I'm going to actually use my via. So while I'm routing, I've already started the trace. I hit asterisk, there's one via. That jumps me to the other side of the board. So now I'm on the back. And to get back, I place another via, and I can keep going. So using vias is a good way to duck under things and get around obstacles, but you want to be careful because you want to try and keep your via usage to, I want to say, a minimum. They're not wrong to use, but if you could place a simple trace that didn't use vias, you probably should, as opposed to making something that continually switches between sides of the board. That's not really optimal. Because there's going to be a resistor mounted here, through-hole resistor, I can actually go right between these pins. There's no problem with doing that. Oops, I'm going the wrong way. What I want to do is this. Yep, no problem with going under that resistor. Sometimes you want to avoid that. For example, if I have a component that's carrying a large amount of current, or it's going to be a really noisy signal, I might not want to route it under something sensitive. Likewise, if I have, let's say I have something like a motor driver, and it's supplying a large amount of current to a motor, I would not necessarily run a data line underneath a component like that because I wouldn't want the interference or the noise or whatever to have an effect on my sensitive signal. That might not be a concern for a lot of projects, but it is best practice and it's something you want to think about. So that's why I mention it. So I like the way this is coming out so far. Obviously, the thing about routing boards like this is that there are a lot of correct ways to do it. There are a lot of ways that are technically correct but are not ideal necessarily. So I'm sure if I showed this to somebody, and this is something you should do, feel free to bring your PCBs to M5, ask a couple people to take a look and give you some feedback on your routing. That's a definitely a good thing to do before you send out and order a board. I'm going to set this so it's as thick as all the other elements, right? 20, and then these are all 25. That makes sense. Cool. So I think I like that. And you can see I have no more of those connection lines, which means I've successfully connected everything in this design. So now let's fix these sharp corners that we don't want. So how do we fix those? Well, the easiest way to do it is once you're done, we go to Tools, you go to Teardrops, and then we get this dialog. And this does a lot of things. So this actually will smooth out the connections from trace to via, from pad to trace, between two different traces of different thicknesses. And what we care about right now is the T-junction. So we're going to unselect these three things and have T-junction selected. I have my style set to line. You can use curved if you want, but I think line is, I don't know, it's more appropriate for this. And I have it at 100% and 300% for the width. And so you'll see what these do. If I just press OK, it's going to go through all over this design, and it's actually going to chamfer that connection. So now I no longer have that hard 90-degree angle there. It's actually much smoother. And I need to go around and just quickly make sure. So there used to be other ways to do this in previous versions of Altium. There are a couple other methods that are not as nice and easy. The only thing I noticed is right here it didn't do it. So that's not great, and I wonder why that is. So maybe it didn't. Yeah, this is why. So look, there's a little track here. So it wasn't technically a T-junction. So instead, let's make sure there's actually a proper T-junction there. So you always got to double check. Altium has great tools, but it pays to be careful and double check those tools. There we go. So that looks really good. All right, so let's move on to the next step. And the next step is going to be those ground connections that I keep putting off. So we're finally going to do them. Let's save what we have, and let's talk about it. So what I want to do is go to my tools. And there's a tool here called Polygon Pour. I can go to Polygon Manager, and I get this dialog box. So I can see the silhouette of my board, and I can apply a new polygon from board outline. And I'm going to set it to the top layer for now. So on the side, I can see this is the polygon that I'm designing. I'm going to tie it to the ground net on the top layer. The name, you can set a name for it if you want to. I think this is fine. And then I get some options. So I can remove islands. Islands are regions. Now let me see what this does first. What this does, if I click Apply, OK, is it fills in all the rest of my board with copper. So what that means is that instead of routing away all of the copper when they go to mill this board, instead they're just going to route little channels between my electrical connections and the rest of the board. And then all the rest of this copper is electrically connected to these ground nets. So that's exactly what I want. And I have a couple options when I do this. So if I go back to the manager, let's take a look. OK, so I go back to the manager. I can see I can remove regions that are too small. I can remove regions that are very, very thin. Yeah, there's a lot of settings here you can play with. I don't think I want to get too into it. I'm going to add another one from the board outline. And this time I'm going to use the bottom layer. I'm going to hit Apply. And now I have one on the bottom. So now I can click and I can see these are my two polygons. I'm going to use them in the final design, and I'm going to hit OK. And there they are. So when I switch layers, I can see them. This looks great. Let's see how this PCB is going to look. If I press 3 on my keyboard, I switch to 3D view, hold Shift, right click and drag, and I can move around. And I think it looks pretty good. So my resistors don't have 3D models. That's OK. Yeah, so this is how the board looks. It's a very simple board. Yeah, I think it's pretty good. So I'm going to hit 2, go back to 2D view. Let's say I need to make a change in this. So the only problem with these polygon pours is that now, let's say, I don't like this trace for whatever reason. I want to change it. I can hit Control W and I can start rerouting. and I'm immediately going to get errors. So what are these errors? If I right-click on this, go to Violations, Clearance Constraint, and Short Circuit Constraint, which obviously, as you can see, this track is now intersecting with the pore. So what do I do about that? If I go to Tools, Polygon Pores, I have the option to shelve two polygons. And what that means is basically hide them for now, and don't consider them when we're checking rules. So if I undo, yeah, there's a bunch of big errors. Let me redo. So now I can, I actually kind of like how this trace was before. I think I'm going to do it again. Cool. Yeah, so what I need to do now is go to Polygon Pores, and I can re-pore all polygons. What that means is it's going to reconsider. Actually, hold on. Sorry, I need to restore my shelved polygons. You can see they're going to be big errors because I've changed things. Now I can go and say re-pore all. And that is going to basically have it recalculate the shape of the remaining copper based on the updates that I've made to all my pads. So I think that's mostly what I wanted to talk about this episode. Like I said, there's so much to talk about when it comes to best practices for routing, and it's going to depend on what you're doing. So there's best practices for high frequency signal lines. There are best practices for things that carry a lot of current or things that we anticipate heating up and getting very hot. We don't want to put those next to very sensitive components. There's a lot to talk about. There's a lot of resources online, and of course, feel free to come talk to M5 staff and have them look over what you've made and ask questions about things you're concerned about. But for now, I think that's going to do it. And in the next episode, we're going to talk about generating Gerber files and uploading them to a manufacturer's website. So thanks for watching. Let me know if you have any questions, and take care.